While we'll be diving deep into a variety of techniques for data analysis as we move through this course, this is a good time to cover one of the most overlooked aspects when it comes to comparing two laps, and that is the parameter we use for the x-axis of our graphs. There's actually a hint in the name, as often these graphs are referred to as time-distance graphs. And yes, the two channels we would usually choose are either time or distance. The problem is that when particularly it comes to analysing two different laps at the same racetrack, what we're really interested in knowing is where on track something happened rather than when it happened. For this reason, we want to make sure that for most of our analysis, the x-axis or horizontal axis on our graph is displaying lap distance, not time. By setting the axis to time, understandably, the faster car will get to a particular braking zone or corner sooner than the slower car, so it's not possible to learn anything from braking points or where the driver is able to get back on the throttle. This effect is made worse as the lap progresses and the time variation continues to increment, and at a glance it appears that the two laps provide little meaningful data. As soon as we switch the x-axis from time to distance, the data appears to align and the braking areas and corners occur at the same place, making it possible to perform some meaningful analysis. To highlight this, let's stop now and have a look at the differences between using time and distance with some real data. Here on my screen I've got an example of a typical time-distance plot, which in this case I'm looking at with the VBox Circuit Tools software. Here I've just got a simple plot of speed, longitudinal acceleration and lateral acceleration for a single lap. The most important thing to realize here is along the horizontal axis down here, we've got the axis set to distance. We can see that really clearly with the numbers here. They kind of make sense to be a track distance in meters. At the top of the context control here, we've got the option to switch between time and distance. So if I click that to time, that horizontal axis now becomes time. If the axis is set to time, it's the time since you crossed the start line at the beginning of that lap. If you have it set to distance, it's the distance since you crossed the start line at the start of that lap. We can move through the graph and analyse different sections and different details in the same way as whether it's time or distance. That doesn't really change. As I said earlier in the module, the reason we usually have this axis set to distance rather than time is because we're usually interested in the position something happened on track rather than the time it happened. I think the way this becomes really obvious is when we add an overlay lap on top of the reference. So if I add here an overlaid lap, so the primary lap, which is showing in red, which is set as our reference lap, is 108.21, and the overlay lap is a 110.12. So the red lap is the faster lap. We can see that first by looking at the variance plot. We can see the blue lap losing time as we continue on during the lap. And to start with, you can see here I've got the x-axis still set to time. Now, one of the ways we can identify the position on track is by looking at the position of the lowest speed at the apex of each corner. So this blue lap is relatively consistently losing time as you move throughout the lap. We can see here at the start that the apexes of the first corner are more or less aligned, but as we move through the lap, these are getting further and further and further apart. And that's due to that time distance, as because we're measuring against time, it means that part of the lap is happening later into the log file compared to the faster reference lap. So we can see these same features happening everywhere. We can see this in the lateral and longitudinal acceleration. These same features are becoming stretched the further and further you move throughout the lap. Now, if we move to looking at this in terms of distance instead, you can see that the features are now really well aligned. Even though one of these laps is significantly faster than the other, we can now see that the features of the track, as in the apex of each turn, are more or less lying on top of each other, which is what we want when we're analysing driver performance. One of the times you will tend to use time on the x-axis as opposed to distance is when you're looking through a time-distance plot at reliability channels. However, when it comes to analysing driver and car performance, you're almost always going to be using distance on the x-axis. That was just one of the modules taken out of our Data Analysis Fundamentals course. If you want to become a better driver, get faster lap times, and constantly progress your driving skills, you'll need to know how to use a data logger and understand the information it gives you. In this course, you'll learn the different types of logging systems and what will work for both your needs and your budget. You'll learn the fundamental cornerstones of data logging and analysis that'll form a strong base that you'll be able to build on for the rest of the course. Next, you'll learn all about the bare minimum sensors needed to start analysing your driving. And after that, you'll learn about your logging setup's more complex functionality, which you'll be able to make use of as your skills and experience increase. To ensure you're able to put the theory of what you've learned into action, there's a detailed practical skills section that shows the concepts explained in the course being applied in the real world. Finally, you'll learn the 6-step data analysis process that'll give you a clear and structured template to work from as you embark on your own data logging projects. If you want to find out more, click the link in the description.